Hi, we are Group 13. In this video, we will show you a large part of the component app, the thread design diagram, and our task division.
So my name is Kunlong, and I'm responsible for integrating the OpenAI API in our app. On the search screen, users can create their own personalized routes and ask the AI for place recommendations. For example, let's say I finish my morning class at SFU and I want to find a pizza restaurant on campus for lunch. After that, I plan to meet a friend at Metrotown, but he isn't home yet, so I want to look for a library where I can plug in my laptop and wait for him. So I can set the first location to SFU and type pizza restaurant and set the distance to 2 kilometers. Then I set the second location to Metrotown and type library and set the distance to 3 kilometers. Additional requirements will be I can plug in my laptop. After that, I can just let AI handle the rest. When the user click Ask AI for advice, first in search fragment, the button's click listener kicks in. It does a quick check. If the form fills out properly, it shows validation errors and a toast message. If everything correct, it called Ask AI for advice. The Ask AI for advice function grabs all the root data the user entered from the adapter and passes it to the view model by calling Ask AI for advice with root nodes. And then in search view model, the function ask AI for advice with root nodes just set its loading to true, which makes the button show loading, and it sends the root data to prompt builder. The prompt builder takes you root info like location, place, distance, and builds a detailed prompt with examples. You use build prompt to format everything nicely, and then call OpenAI service. Finally, OpenAI service makes the actual HTTP request to OpenAI API using OKHTTP, gets the AI response and send it back. The response then show up in the UI.
Hello, I am Jun Hyeok Park, and I'll show you how I implemented Firebase integration for saving routes and favorites in our Route Node Android app. I'll demonstrate the favorites system, how routes are stored in Firestore, and how they're displayed on the map. First, let me show you how users can save routes as favorites. When a user generates AI advice for a route, they can click a star button to save it to their favorites. The system creates a route object with all the route information, destination, distances, and user details. It's saved to Firestore under the favorites collection, organized by user ID. Each favorite includes the creator ID, so we can't track who saved what route. Users can remove favorites by clicking the star icon or using the menu options. The UI updates automatically when favorites are added or removed. The database is built using a hierarchy Firestore structure. At the top level, I have a favorites collection where each user gets their own document. Inside each user document, there's a route subcollection that stores every route the user has saved or marked as a favorite. Each route document contains the full route information, title, description, waypoints, distance, and a creator field, so we know which user saved it. This structure is simple, scalable, and keeps data cleanly isolated per user. All database operations run through a repository layer. The repository provides suspend functions like save favorite route, remove favorite route, and get user favorite route. These functions run inside Kotlin coroutines using View Model Scope library, which keeps the UI fully responsive. Firestore returns tasks, so I convert them into coroutines using await. This makes the database API fully asynchronous and easy to work with. The view model exposes live data and state flow, so the UI automatically updates when data changes, such as when a user favorites or unfavorites a route.
Hi, my name is Tushar, and I'm responsible for implementing the authentication feature in our Route Node app using Firebase. When the app launches, it opens with a sign-in screen. Here, the user can log in with their email ID and password, and I have also added a toggle to show or hide the password. And if the user is not registered, they can tap on sign up text here, and this screen creates a new account and securely stores it in Firebase using Firebase authentication. For example, I've already created an account, so I'm just gonna log in. Once signed in, the user is redirected to the main screen. No credentials are hard coded, everything is handled through Firebase. And in the account section, I displayed the user's email dynamically by retrieving it from Firebase, so it's always accurate for the logged in user. And once the user clicks logout, they are returned to the sign in screen using Firebase built-in logout method. And that's a quick overview of login, registration, and logout functionality I worked on.
Hi, my name is Anh, and I'm responsible for the account page features, which include the setting page, profile editing, and password change functionality. So in account fragment, we have 4 buttons: my profile button, setting button, AI button, and logout button. But for this phase, we only implement my profile button, setting button, and logout button. For my profile activity, it displays the user's full profile by loading information from Firebase Authentication and Firestore. The screen also provides 2 buttons, one to edit the profile and one to change the password. For change password activity, it lets a logged-in user securely update their password. It first reads the old, new, and confirmation password from the input field, check that all fields meet the condition, and then it re-authenticates the users using their old password. If re-authentication succeeds, it updates the password through Firebase authentication and shows a success message. Otherwise, it displays an error. For setting activity, it manages all the setting preferences. It loads the saved value from shared preferences. Theme changes are applied immediately using app compat delegate, and the selected theme is restored on the future launch.
Hi, my name is Eric, and my job is the map part of our app. So when you press the button, you are taken to a Google map with your current location, and in the bottom is a list view of all pins that users have posted. And if you press on the pin itself on the map, it'll give you the stops in which a person had published from their AI response. And if you press yes, we'll pass over the longitude and the latitude, and it will give you directions to where to go, and it'll give you the estimates and all that. We are using the Fuse location provider, and so that will be used to track the user's position. And so what we have is that it will ping 5 seconds, and that it will need a minimum update distance of about 1 meter. And then if those happen, then it will update. And during that update, in our callback function, we'll be updating the user's lat long, and then updating the user's marker on the map, which was the blue one. So this part right here is going to bridge the gap from the AI feature of the app to the maps, and that is we are going from the AI, we are going to put extra the longe and lats of the areas that it gave us into the map activity, and then we are going to deal with that later. But for now, we are using hard-coded values. So in our observe view model, we are going to be using getting our pins. So we are going to fetch the user pins, which right now are hard-coded values. So right now we're fetching from this. And this is for printing them into the text view in the bottom using a recycler view. So we are going to go through each and say, stop this one. Is that destination? And its location is going to be the lat long, and this will eventually be prettied up. And then when you click on it, it'll ask if you want to go on it, or if you don't. And if you click yes, this will open up the Google Maps.
Now I will show you our thread design diagram. This app tries to keep the main thread free so the UI feels smooth. The activity and the fragments runs on the main UI thread. They show the screens and handle tabs. When a user does something, the activity calls a view model. The view model starts a coroutine with view model scope.launch. Inside that coroutine, slow works runs on background threads, usually with suspend calls. And the slow work includes network calls to OpenAI and Google Maps, Firebase read and write, and the room database query. And these jobs do not block the UI thread. When the background work is done, the coroutine goes back to the main thread. The view model updates live data like it's loading, error message, or data list. The UI observes live data and refresh itself. Some Firebase codes also use listeners. Firebase runs them on its own thread and then calls back into the app, which then updates the UI. Here is our task division. And here is what we will do in next phase. Thank you for your listening.